Welcome to This Is My Architecture. I'm Matt from AWS. Today I'm joined by Amreth from T-Mobile. Thanks for joining.
Thanks, Matt. Thanks for having me here.
So I'm a T-Mobile customer, but you guys are also a customer of AWS, right?
Yeah, that's pretty good.
So you're doing a lot of innovative things in the mobile space, but also a lot of innovative things in the cloud.
Yes, absolutely.
Cool. So up here on the board, I see we're going to talk about the anatomy of your container workloads. Is that right?
Yes, yes. We have a pretty cool story to share today.
Cool. So tell us about why you built this platform in the first place.
Yeah, so we had a lot of teams that actually wanted to build microservices, and so we are in the center of T-Mobile, talk to multiple teams, and we actually know the requirements, and we talk to teams about what is coming up. So we saw a need to build a massive container orchestration platform, and so that's where it all started. So 2 years back, we did a few POCs and then narrowed down like Mesos was the most stable orchestration framework that was available at that point of time. So then we tried creating all the instances with the entire cluster with Mesos Marathon, and it's been 21 months and zero downtime in our production cluster.
Oh, congratulations, zero downtime in 21 months. That's impressive. So yeah, 2 years ago, Mesos Marathon was the stable best bet. You know, a lot is changing. This is a fast-moving space. Are you considering the ECSs, EKSs, Kubernetes of the world these days?
Yes. So we have like 3 Kubernetes clusters that's running on AWS, and we got preview for EKS as well. So that way we are doing EKS related specific workloads. So we deploy a few containers on EKS. So whenever it goes GA, we'll start using it for production.
Cool. So we'll have you back in a year or something and see where you're at.
Absolutely.
But in the meantime, let's sort of look at the anatomy of your Mesos Marathon cluster. So first of all, you said there's a lot of different groups using this cluster. Like at other large companies, I imagine they're not all using the same frameworks, not all using the same languages. What types of applications are people deploying into this cluster?
So we have various different types of applications. Like one cool thing is like we have a .NET application running on Red Hat.
Oh, so .NET on Red Hat. That's cool.
Yeah. That's pretty impressive. Then we have Golang applications. Then we have Spring Boot. Then even we have like proxies like Nginx and Apache and all those different.
And you're able to do that in these shared clusters.
In the shared clusters. So so we have like various agents that runs. We have teams that want dedicated agents due to some compliance and all those things. We run dedicated agents for them. So that's where all the agents come in.
And give us an idea of scale, maybe. Like how many applications, containers, how big are these things?
Yeah, so we run about 2,000 plus containers, and like there are like 500 different EC2 instances. So that's the scale of our platform.
Great. And is this multi-AZ, multi-region? How big are we?
It's multi-AZ and it's multi-region, and some are active-active as well.
Active-active multi-region.
Yeah.
Oh, cool.
So so we have a global load balancer without traffic between the multiple regions. So that way, due to some business requirement, if you need a very high availability, we are there to support that requirement as well.
Okay, so not just HA and DR, active-active, multi-region, global company, global infrastructure. So let's pick it apart a little bit. So if I'm going to use this cluster, tell us about how you first get access to this cluster.
Yeah, so any of the access that comes into this cluster is through a load balancer or through an API gateway. So we use both classic load balancer and the network load balancer.
Why do you use both?
So the network load balancer, like very recently, AWS released a cool feature about if you're using API gateway and all the access earlier used to go via an internet to access the underlying resources. So now they have introduced a VPC endpoint. So we use network load balancer for that. So we route all the traffic from API gateway through network load balancer to the HA proxy. So that way, all the traffic that is all internal to a particular VPC.
So this is all internal within a VPC?
Yes. So this entire thing is within a VPC.
Okay.
And this is again a separate VPC.
Yeah.
And I just name it VPC 1 and 2.
And I imagine these VPCs have to talk. Are you using VPC peering?
Yeah, absolutely. So it's peer.
Okay, cool. So you have peered VPCs. So container orchestration frameworks, you have schedulers, you have monitoring, a lot of components. So tell us about the different components you're using. Obviously, Mesos Marathon at the core. You said you have HA proxy here. Walk us through the different pieces here.
Yeah. So the masters, we have Mesos, we have Marathon, we have console for scheduler, and we have service discovery console. And so that's what we are running here. And we have agents where we actually run Docker. And that's where all the microservices and containers runs here. And HA proxy is running as a container on these EC2 instances, and it's scalable as well. So we support thousands of TPS because of different massive workloads what we run here, and HA proxy supports all of that.
Cool, up to thousands TPS, that's very cool. So you said scaling. How are you actually scaling this? Or are you monitoring? What dimensions are you using to decide how big or small to shrink your cluster?
So scaling, we do it in two levels. One is the container scaling, and other one is the infrastructure scaling. So we have custom scripts that we have written for both. And so for the infrastructure scaling, which is on the EC2s, we have agents running here on the agents that sends data to CloudWatch.
What kind of agents are you running?
So we run Mesos agents there, and for different environments, we run like various different EC2 instance types. So that's where all our containers are hosted.
And then for metrics, are you running some kind of a metric collection agent?
Absolutely. So we run collect D.
Collect D, okay.
To actually get all the metrics from here. And so actually we send it to CloudWatch, and collect D also pushes it to Prometheus.
Okay, cool. So you're using Prometheus here. A lot of choices in this space, in the monitoring space. Some customers using Graphite, you're using Prometheus. Why do you choose this one?
So Prometheus is actually, when we initially started, we used Graphite. So Graphite, when we started scaling up huge, Grafana and Graphite together is like, it became extremely slow. And every single time we had to increase our instance capacity to support massive workloads.
So you're monitoring your monitoring solution all the time.
Yeah, exactly. So we had a monitoring on top of monitoring solution, and it kept getting alerts and all, and then we realized, right, okay, hey, you know what, we have to change our monitoring to Prometheus. So we did a POC, and it worked really great. And now we run all our metrics in Prometheus, and we feed about like 2,000 TPS data to Prometheus every single second. So that's the amount of information we collect to Prometheus.
Wow, so 2,000 TPS, and I imagine you're using it with CloudWatch. You get CPU and the other metrics you might be feeding CloudWatch in addition to the stuff you push.
In addition to that. So we use CloudWatch Exporter to feed data from CloudWatch to Prometheus. So Prometheus becomes our integrated kind of a data lake. So we store all metrics on top of Prometheus, and we use Grafana to visualize, and we have built some custom monitoring telemetry sort of sites where people can go for self-service. So any team who actually wants to come and check their the CPU, memory, network, they can just go to the site and they can just see every single thing by default.
No wonder you have no downtime. That's great monitoring. So monitoring is a big piece of it. Two other pieces I want to touch on with you. The first is security. You have IAM here. Something some people struggle with when they're working with containers like Mesos and AWS. How are you handling the integration of IAM or security in general with your container platform?
So since this is a shared workload, and we have like a lot of different applications it's accessing, and each of those applications will have specific EC2, load balancers and KMS and other integrations. So we don't want each applications to step on each other's, and we need more security to be SOX compliance, PCI compliance and all. So for all those compliance aspects, we use IAM role to restrict access between the containers itself. We use metadata proxy to manage control between different containers that runs in the shared cluster. So that's when IAM plays a very key role to provide us those level of security.
Fine-grained access control for containers. That's cool. And then I see here you also have Dynamodb. Is that to store state or what persistent data? What are you storing in there?
So the entire cluster's metadata is stored here. So in the event of a massive failure of the entire cluster, we replicate this entire cluster as is using this metadata, and in about 7 minutes you can have this entire cluster replicated on another region, or even within the same region as well, in case this cluster goes down for some reason.
Our CTO famously says everything fails all the time. So this is 7 minutes to bring up the whole cluster is great. So you have multi-region active-active. You're using fine-grained access controls with IAM. You're storing your state in Dynamo so you can have quick recovery. You have a really robust monitoring solution, service discovery with HashiCorp console. It's a really great architecture. Thanks a lot for sharing it with us.
Thank you. Thanks a lot.
And thanks for watching. This is my architecture.